I'm going to deep dive into some technical stuff today. It's a travesty when you hear previous speaker talk about AWS did this, Alexa did this, Baidu did this, Google did this, Facebook did this. When will be the day when somebody says Flipkart did this, right? So that's kind of what is bothering us, which made us start Isima. Some people told me yesterday that we have not told a lot about who we are, what we do, what product we give, all that. So I'm going to spend a little bit of time on trying to explain our backgrounds and still not try to do too much selling because we don't believe in it. We are engineers. So let's dive in. Looks horrible here because of the screen. It's not my fault. I'm using Google Slides. But this is about us. Me and my co-founder started Isima about 3 years ago. I'll give you a very different introduction because this is a technical group. Just a little bit about our chairman, Ken. Yesterday in that CXO dinner, Google Cloud came and showed us, hey, they can detect emotions on people's faces and whatnot, right? It seems to be now vogue and commodity. Ken built a company called Emotion, which was in 2012 doing that, long before none of these big guys were doing it. He's
You can use this one.
Hello?
Yeah, it's better. No, I don't need this. Okay.
Wasn't comfortable anyway. So Ken built this company called Emotion, which was sold to Apple. How many of you have iPhone X? You know the Face ID technology in there? That is their tech. So even Apple couldn't build it, and they had to buy that company to build it, right? So they were using whatever the buzzword you want to use, deep reinforcement learning, whatnot, long back. Can't hear you? Better? Okay, cool. So these guys were using all kinds of machine learning techniques long before. I've known Ken for about 10 years. He was trying to hire me for Emotion and whatnot. But I'm going to give you a very different introduction about me and Manish. And I will have to switch slides for it because I created this 5 minutes before the presentation. We are all engineers. We all do everything at the last moment. This is 2 decades of timeline. Right? And you should always look back at history of data. I said, look back at the mothership of data. Don't look back at the FUD that you are getting every 6 months. So the revolution started with Google. Google begins in 98. And Google writes the Google file system paper, doesn't open source it. It comes from the ad systems world, right? It's all designed for Google ads, essentially. And then Yahoo creates Yahoo Hadoop, and then Cloudera begins, right? This is kind of the birth of what we would like to say, quote unquote, the big data movement and all of that stuff. The second thing that happened was Google wrote the big table paper, which powers real-time ads. When you do a search, when you do whatever. Even today, $90 billion basically runs on Google Big Table, right? And Amazon created the DynamoDB paper. Facebook open source Cassandra. And data stacks begin, right? Everything else is just echoes of these 2 movements, essentially. Right? No matter however you look at it, Mongo and this and that, and new technologies coming around, SQL, big data, whatever you want to call it, we are just living in the echoes of this world, right? And there's 2 other companies that started, which many of us don't understand from a data perspective. There was one, Nutanix, which started around 2008, 2009, and there was Pure Storage, which started around 2008, 2009, right? We all know what is happening to Cloudera from a public perspective. We all know what has happened to Hadoop, so I'm not going to belabor you. DataStax is still not IPO. I was their head of product, and you can blame me for that a little bit. But it's interesting that two companies which bet against the cloud, right? These are hardware companies. They build appliances. They didn't build, like Pure Storage actually build a foundation, storage, right? It's a NetApp filer. It's NFS. I mean, it's as boring as it gets. These are $20 billion IPO companies, and they're going gangbusters right now, right? They don't open source. They may use some open source, but they eventually throw it away. And they build amazing product companies in spite of all these movements that we are seeing right now, right? So now let's, in this context, see what Manish and I did, because we both spent 2 decades in Silicon Valley, roughly. Manish, who was my manager when I first reached the shores of Silicon Valley in 2000, I've known him for 2 decades, like it or not, and I still decided to work with him. He did zero copy in FPGA in 2002, before Linux had it. How many of you know what is zero copy? Very few people. Okay, you know that? Great. So zero copy is basically from the network to the disk. How do you do zero copy? It's the founding principle of how distributed systems are built. And he did it in 2002. He built an entire filer in hardware. It was kind of used in supercomputers and whatnot. There was a distributed file system called Lustre. How many of you know that? It came from Carnegie Mellon. Peter, forget his name. But he deployed at Lawrence Livermore Labs, the largest parallel file system on the planet at that point of time, and probably even today, right? And then he went on the consumer side and built this appliance called Drobo, which essentially it's like a storage DVR. You never run out of storage. When we go and talk to VCs in Lightspeed and Anderson and others, they say that I still have a Drobo at home. For 15 years, it's been running and it has never gone down, right? That's the level of resiliency of products. Still unable to hear me? Speak loud, that's it? Or shout? Okay, all right. Yeah, not used to this too much. So that's what Manish did. This is our CEO. Some people joke that if I cut his tie, he'll start coding. That's in a nutshell what it is, right? But he has also built, he has raised $650 million, built an IP company out of India, which rivaled the IP filed by Caltech by... Is it okay? Yeah. Hello? Better? Cool. Finally, something works. So he did that, and he actually created IP out of India, which competed with the IP out of Caltech, right? Out of Berkeley, out of like these fundamental innovations in biology, not just computer science, but in biology and everywhere else. And from IITs, then he replicated this model in China, Korea, Japan. He went back to US. And he was actually looking at hardware systems, flash, and how many of you know 3D XPoint? Okay. There are 2 people, I'm very proud. There are 2 people and 2 girls. You should come to Silicon Valley and tell them how girls do code, right? But 3D XPoint is the new class of memory after 25 years. Flash was introduced in '93. This is the first time after 25 years that a new class of memory is appearing in the memory hierarchy. So he was looking at manufacturing plants and talking to Micron and Samsung and all these guys and said, how can this thing be used for big data? So that's how we again connected and started talking. A little bit about myself. I had to build my own Cassandra from scratch in 2001, 4 years before Bigtable and 7 years before Facebook open source Cassandra. So I joke around that NoSQL came from telcos. It didn't come from Facebook or Google. They wrote good papers on it. But if you look inside a telco box, they always run NoSQL, right? They never run SQL. I had to do, at Yahoo, I did click fraud in 2006 before Hadoop existed. I told people that we didn't use Hadoop. I did the math. Hadoop was a piece of crap for Yahoo himself, but we sold it to the rest of the world, right? And then I went to a hedge fund, D.E. Shaw, and built TCP on top of UDP. Because again, this was ultra high frequency trading on the same LAN as NASDAQ and NYSE, and TCP is the bottleneck. If you see HTTP 3, which is what Google is pitching right now, HTTP 3's founding block is TCP on top of UDP, right? And so I again joke that hedge fund guys, Google is 10 years late, hedge fund guys already did it 10 years ago, right? So that's kind of the world that we come from. And going forward, I deployed Cassandra for customers like SoftBank, Time Warner, Virgin Media. I funded features in open source like Spark, like Cassandra. How do you do idempotent counting in a distributed system without a lock? Very hard problem, but you have to solve it for messaging. Now we call it the iMessage revolution. This is not just any messaging, this is iMessage. iMessage in Japan goes to the backend we build. It's the only country in the world where it doesn't go through Apple, right? And how do you build a tsunami resilient messaging system with telco grade, whatever you want to call it, right? And then I went to join DataStax. I became their head of product, tried to sell these technologies to the rest of the world and said, hey, you guys can also, how can machine learning get democratized and use it? And I came to realize that the last decade of big data is the lost decade of big data. We just wasted our time. So we started Isima in 2016 to change that, me and Manish. As you can imagine, I was looking at graph databases in real time, and Manish was looking at hardware, and we tried to meet somewhere in between. We had a key FF&E, which I won't bore you with, but our end goal is, and this is where we're going completely against the grain, but how can on a 1U box, just 1U box, right, you can run a multi-petabyte real-time graph, right? That's what will make all of these things happen, because that's what our brain is. Our brain is fundamentally a real-time graph on a single head. It doesn't have scale out. But we kept on selling scale-out technologies and cloud and all of that to the world, right? So now that I have told you what we are at, or what our backgrounds are, because again, going back, so I'm again offering you this. I'm not going to make it easy for you guys. I'm not going to sell you AWS did this and all of that. I'm just going to tell you honesty. But we'll go very deep. Let's look at some fundamental principles of the last 60 years which guide us, right, in the technology world. And these are some, you obviously have seen Moore's Law. Moore's Law basically doubles everything. Network effects, this was founded before the Cisco systems take over and before the internet. As you add more devices, things grow, and that's what Facebook is, that's what WhatsApp is now, in many ways. Adding more people to the project will make it later. How many of you agree with that? Pretty much everybody. But no manager understands it, but we still have to. Why can't we add more people to it, right? Isn't that what it is? There's another law which I think is very apropos to the big data world, machine learning world today, right? Conway's law states that people design systems which replicate the organizations they are part of, right? This is very interesting because if you go to look at a microservice architecture and a two-pizza team, it's related to this. And if you look at waterfall, which telcos do, it is related to this, right? I'm going to add one more corollary to this. Any solutions and any helpers that come out of there, open source, cloud, whatever you want to call it, they work to enforce the survival of the organization instead of the business, right? And I'm just going to spend the rest of my time trying to prove this and go very deep at every single level. So, how many of you have worked with data before the big data revolution? Like, how did we do? Okay, there are a few. Good. So before this whole big data movement started, we had a stack which was something like this. There was an IBM MQ series Q, there was ETL processing, there was SAP business objects, there was Oracle, there was Teradata. Believe it or not, 90% of data is still here, like it or not. 90% of data in the world is still sitting here. Go inside, and it's crazy. It's a travesty actually, but that's where reality is. Then we got the first installment of quote-unquote big data after Google papers came out, right? And that looked something like this, right? You got a better queue, you got a better UI, you got better the Hadoop MapReduce came out. There was HDFS, which came out. And there was MongoDB which came out. By the way, all of Mongo and HDFS came out from the ad world, right? I mean, Mongo came from DoubleClick and HDFS came from Yahoo, right? And then we are now living in this second or the third generation of it. There's another better queue. MapReduce was a piece of crap, so we created Spark. We engineers, I say that in Silicon Valley, we like to build inefficiency and then try to catch up. Like the worst thing to do, but anyway, it's life. Then we created an indexing system, and then Elastic Stack is pretty brilliant. And oh, by the way, HDFS is bad, so we'll use S3, right? So it's like, seriously, guys, what have you changed for the last 30 years? Somebody has to look at this, right? There's a dirty word for, and again, I'm dating myself, it's called EAI. We used to say that, these enterprises, they do enterprise application integration. They just keep on focusing on that. We do the cool stuff, but the enterprises, they work on EAI, right? I like to think of this as EAI, EAI++, and EAI rise to 10. This has gone mad now. Every day, a NoSQL pops up in Silicon Valley funded by Lightspeed or Anderson. Toothbrushes like a supermarket. Nobody's trying to look at the whole system because it's very difficult to look at the whole system. We have been doing this. Like it or not, there's an enterprise service bus, there's ETL, there's enterprise data warehouse, and there is BI, fundamentally. And you look at vendors, each vendor is trying to help you solve that. Now, they may call it as streaming, they may be calling it queuing, we can do SQL on top of this. You go back to 2002 and there was a company called Streambase, which is used in finance, which was doing SQL on streaming. Now, they were not as good as, scale out, but fundamentally they're all doing the same thing, right? This is the problem. This is the problem which we have never innovated out of, and no startup gets funded because it's very difficult to solve this problem. Because it requires a systems view. It doesn't require you to think at point products. It requires you to think of the whole system, right? So let's actually look at what happens in today's day and age, and let's look at an anatomy of a click. Okay? One click on an app. Let's say you're a user, and some of you guys, I'm going to use a B2C example, but this applies to IoT or whatever your use case is, right? Let's say a user is browsing Facebook, because that's what people do nowadays, I guess. They're browsing Facebook, they see an ad for your product, and they click on it, right? What happens? That click gets directed to your app on a phone. That triggers some transactional 3-tier stack to come out of it and render the page. The page gets rendered. And then the cacophony begins, as I call it, right? Effectively, there are on average 10 pixels on an app that get fired at any given point in time, all looking at 90% of the time the same data, right? Exactly the same data. You're looking at the same freaking HTTP parameters, right? Then the technology teams, which is in big dearth of, go and build an open source stack inside to using the previous logos that I told you, and they build an open source data platform or cloud, whatever your favorite word. Then it gets even more worse. Then they say that I need that data given to Facebook. Now I need to pull that data back. It's your own freaking data. You're giving it to someone and pulling it back. It's perfect. And you're paying them for it, by the way. And then other sources, right? So this is a beautiful looking my designer did a great job of drawing this. I'm not that good a designer. But in reality, the system looks more like this. This is what we have built in the last decade as engineers. This is every single TCP hop in the system, every single one of them. And this is what it looks like, right? And I've shown this to people after people after people, and their jaws just drop and they say, yeah, this is kind of what I'm building, right? So let's kind of walk through, right? So obviously I talked a lot about the SaaS side of the equation. I'm not going to bore you that with it, but effectively you have an app, it goes to your transactional store. This transactional store runs on RDS or Aurora or something of that nature on the cloud. You get all this data going into some sort of a queue. I don't want to bore you with that. Then it goes into some sort of stream processing. Then it goes to some sort of distributed storage. By the way, guess what? Data goes out of sync. You build a reconciliation layer for this. Then you build it into what's called the serving layer. We have a Lambda architecture, right? So we should have serving layer caches. Then it powers some microservices, which is where your machine learning model actually runs, right? The dynamicism of predicting search or pricing or inventory or anomaly or whatever it is that you're trying to predict, or an image, right? hold on for a moment, because these SAS pixels are too noisy, so I'll put segment and I'll get all that data from there into S3, and then I'll build some Redshift data warehouse. And then they will complain that my queries take 30 minutes to run on Redshift, right? But this is what we have built. And just being absolutely blunt, we actually sat down, let's say that one of the top 5 companies in India, without taking their name, and we sat down and actually did this with their teams. Where does the data flow? Let's draw the whole darn thing, right? This is a very cleansed version of it, because it doesn't fit in a single slide. This is what we have built. And when you show this to a data scientist, now you start realizing why some of the challenges are, because it takes forever for any machine learning to go live. How do you do security? How do you do governance? How do you do bias detection? If your model atrophies, how do you know that, right? So now let's see if the cloud guys help us, right? So Aurora DB is the fastest growing product on AWS since the launch of AWS in 2006, right? I mean, this is Aurora DB, this is AWS, it should be pretty good, right? So 2019, they released this paper which kind of did a big hoo-ha about how good our internal architecture is and whatnot. This is what that looks like. Just one piece of that whole stack, I'm just trying to drill down into it and trying to explain what that looks like. There are about 5, they call it the bird's eye view of Aurora DB, because if they tried to show it exactly what I did before, it would look pretty ugly. But effectively, there are 7 AWS products glued together to build Aurora DB to give you a MySQL-like interface, right? Now, Amazon being Amazon is pretty amazing at doing it. It's all shielded from you and whatever it is. But in the end, who pays for this cost? Somebody has to pay for it, right? It's not free lunch. Now, Amazon can keep on making losses, but at the end of the day, it's just subsidizing one product with another product. But this is a freaking mess. I mean, if this is what distributed systems have come out to be, then something is wrong, right? When you show something like S3 here, S3 under the hood is pretty freaking complex. It's not easy, right? But this is what is being sold to, this is the cutting edge of cutting edge. This is 2019, right? This is not, I'm not talking of old, but that's what we have built, right? Like it or not. So what has that given us? It has given us something like this. There's a company which has raised $1 billion in India, 1 billion, and you can probably count on your hand, right? There are not many companies, without talking their names. We did a pretty good job of building the model, we couldn't put it in production. Best data scientists in the world, no dearth of money, they just couldn't compute the features in real time. Done, right? Now, if these guys are suffering with it, then what hope is there for the rest of us? There's another company which is a 15-year-old giant in India which said, my ML engineers are hired, they do data engineering 80% of the time and they leave because guess what, they're bored, they're mathematicians, right? They're not interested in all the plumbing. But it gets crazy. A Fortune 100 company is saying that we spend 70% of our time on feature engineering, model never goes live, right? This is for online video, if you have heard about Zoom or others, something like that. And then finally, even a fintech company is saying that I have model ready for 4 months, it's not gone live. By the time I put live, India is moving so fast that model is already out of date, right? I mean, what's the point of not making it live? But the best quote I got was from a largest bank in Italy. They spend 1.2 billion on technology with a B, right? I mean, and they spend like 300 million on mainframe today. That's how, they have everything in between. They have the cutting edge of cutting edge and they have the mainframes too. And this guy said, I spent 150 million over 3 years and I see zero value. So I was like, okay, this is too violent, even for me. I mean, I understand like it's painful, but how can it be this bad, right? I mean, it's 150 million is the entire budget of some major technology player here in Bangalore. And he point blank told me, he walked me through every single reason. He said, if I build, he has a skyscraper in Milan, and he says, if I build another skyscraper and rented it out, I would probably get more money. I couldn't talk anything after that. I mean, we're probably going to go and meet him in Italy. Now let's look at cutting edge, right? We all talked, the previous guy talked about OpenAI is doing this and whatnot. Somebody has to go and look at inside the GitHub documentation of the Universal Starter Agent. How many of you have done that? Does anybody know what Universal Starter Agent is? No? Okay. It's all these things that you just heard, this is the mothership of it. They open sourced, essentially saying that this is the universal starter agent based on which we can learn everything. This is the adversarial network theory of an agent and an environment trying to learn with each other, right? The most important foundation for everything that you are hearing right now, right? Unfortunately, nobody goes and reads the documentation on GitHub, right? So this is that documentation. It says that, I mean, it's pretty dumb actually and pretty powerful on both sides, but it represents biology, right? If you look at it, it says an agent is an environment, it reacts, it gets a reward, it learns from it. It's kind of saying in a fancy way what humans do from childhood, right? What it says in there, which you have to read the fine print, is that on the cloud, if your response time is more than 40 milliseconds, this model stops working. That's it. If it's more than 40 milliseconds, it won't work, right? But it's buried deep down somewhere, right? Like you really have to parse that code and understand it, right? Unfortunately, we do because we are boring people and we try to question these things. Now, on the other side, Chicago Mercantile Exchange basically said that they delay the quotes by 100 microseconds to certain players who pay, right? 100 microseconds. That business is worth $100 million. That's it. No model, no nothing, 100 microseconds. That's $100 million. Simple, right? And this is what I did at Yahoo, right? So I explained yesterday, I was in the click fraud group, and I don't know how many of you know, but there's a term called revenue per search, right? It's a metric that Microsoft, Yahoo, and Google competed in, and most people don't know that it doesn't matter how much search you get, at some point you taper off. With 12% market share, Microsoft had the same RPS as Google, 60% market share, right? Because eventually more data doesn't make you better. At some point you taper off for the same problem statement. So for us, I said that our lag was 36 hours, Google was 500 milliseconds in terms of how fast our feedback loops worked. And some product manager came up with the math that for every hour I reduce in that latency, I will increase RPS by X percentage point, right? So I was able to reduce from 36 hours to 7 hours. Don't tell me why we couldn't go to 500 milliseconds. That's a separate discussion. But that 29 hours resulted in $100 million of savings. That's it. No model. I mean, and I remember our data scientists were being rewarded for 0.001% increase in RPS. That's a pretty freaking big deal if you're working on a $4 billion pipeline, right? The bonus of some of these guys were $1 million if they actually made 0.1% go high. And this product manager told me, if you change this, it's 3% RPS. 10 years of data science effort cannot improve 3% RPS in a mature market, right? So that's what I had to do. So this is where the world is, like it or not. And the travesty is that nobody is reading these things. We are just riding the wave almost, right? And so I'll go back to what we do and how to, I think some of these slides I have shown, so I'm just going to repeat it for people who have not seen it. I said that how do platform companies do data? They start with an app first, really the For You app, For You IoT, whatever it is. The models, or whatever we call the logic, is always about building a unique model for them. It's not just about the math, it's about the context and the tribal knowledge of your business domain. They always build for the multi-cloud world. You don't want to become these cloud companies becoming the East India Company of India, where you are handing over their data and they're just taking over the whole market. And believe me, Netflix does this, right? It's not just like we have to worry, even Netflix worries about it. That if I'm on AWS and if I'm using DynamoDB, what happens, right? Because Amazon gets all my data and competes with me on Prime. And then I talked about the data infrastructure where no cloud SaaS, open source, and consultant, blah, 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 right? And so what we do now, just a little bit of, people have asked me this quite a lot, is that we build we give you BIOS. We call it the Business Intelligence Operating System. It's modeled around an operating system. It's modeled around POSIX. How many of you know POSIX? Good, few people at least do. Thank God, the hope is alive. But POSIX was before, if you go back to 1960s, before the Berkeley BSD was formed, everybody was fighting on device drivers, right? My device, hard disk device driver is better than yours. And today, that's what's happening on the big data world. So we just give you an operating system. You work with 3 APIs. Ingest data, extract data, and you forget about everything else and build your model in production. Now, if you note, all of this is interrelated, right? It's not like it's sort of, you cannot do one thing. You cannot say that I'm going to go all cloud in and not have multi-cloud. So we thought about all these problems because eventually BIOS has to run on a multi-petabyte 1U box, right? And no Java will work over there. Sorry, even C might face some trouble, right? The amount of disruption that is going to happen on hardware is going to kill all software for the last 3 decades. AWS just released one box which has 60 terabytes on a single box. One box, 60 terabytes on a single box. No, none of these open source software work on there. That's the other travesty. But now let me give you one more data point. Today, a shipping flash drive which can go in my MacBook is about 120 terabytes. The largest one. The price per gigabyte is still not there, but it's 120 terabytes. There is a server available which has 24 slots of that today, right? I'm not talking of future. So if I took 120 terabytes, put 24 slots in there and make it run, first of all, it won't run, but if you make it run there, you got your real-time graph, right? We are building BIOS for that. It runs on the cloud, but it can run on that. Nobody can run on that today. And that is a reality, which is this arbitrage that the cloud guys do is essentially what nobody has been given from a longest time. And we went back in time, a lot of time, as you can guess. We looked back at 1960s principles to come up with an answer, how can it run on top of that, right? And yes, it is so good that we are not going to open source it, as the previous speaker said, right? If technology is your product, you don't open source it. It's pretty simple, right? There was the other part we talked about which we didn't cover, which is the organization. And a lot of people asked me about this, so I'm going to spend literally 2-3 minutes on it. But I said that computer science went through software engineering maturity, and that's why we have what we have. We have hyperscale systems, we have all of these things. And data science has to go through the same sort of maturity curve. So let's ask practical questions about how that happens, right? Let's say if you're a startup and let's say you're Series C funded, whatever you want to call it, or a big enterprise, how does it look? This is roughly what the organization looks like. You have execs, you have product people, growth people, you have engineering organization, and you have data scientists, right? This is roughly, not to scale, but roughly in place. How does this change? How does this has to change? This is my recommendation. I'm not this is beyond the titles, by the way, guys. So it's not like CTO, CPO, CDO. Just forget about all that for now. Just look at what do people do. You need an exec guy who understands data. If they don't understand data, there is no way that some low-level guy can do whatever they want to do. You need data product managers who understand data products. People tell me that data scientist is the coolest job of 21st century. I think it's the data product manager, the person who actually understands data, right? And there are very few of them. Very few people can understand. Doing product for click fraud is impossible if you do not understand the math and the engineering and everything else. I'll give you an actual practical example. Somebody gave me a classifier which said that it will save you $10 million. And I came up with the math and said the heating cost of those servers is $8 million, right? That's what product management looks like, right? But that's the level of depth you need. You cannot get some suit guy to do it. Sorry, no offense to the people who are wearing suits, but cannot do that, right? Just cannot happen. So the next thing is that there should be dedicated folks who are focused on productivity of data in the engineering org, not on gluing these things. Their goal should be to how can I put ML in production really, really fast. They're all incentivized for the same goal. And finally, there should be lots and lots of data scientists who are continuously experimenting, right? So really, it's about flipping the organization. It's not about building labor, it's about flipping the organization. In many ways, this is very similar to what happened with the DevOps world, right? There was the world when QA engineers would QA people's code, but now QA people build systems so that developers can QA themselves and ensure reliability of quality. Engineering folks have to do the same for the data scientists, right? That's the only way this organization works. And we believe that BIOS is a platform for that organization too, because it changes the game. It makes, and this has actually happened with us. We deployed it at a customer site. I'm sitting in US, I'm on Hangouts. There's a data engineer, there's a data analyst, or data scientist, whatever you want to call it. Many data analysts call themselves data scientists, but they're not. And he says, oh, this data is not clean, this data is not there, it's not joined, oh, I cannot do this. Data scientists are kind of these loosey-goosey guys, right? Like they're mathematicians after all, right? And while he was talking, this person goes and, yeah, keep on talking, right? Yeah, that data is done. It will be available tonight, right? Done. That is magic, right? Because now that whole problem of, and the data scientist is put on the spot, right? And he's like, okay, now go and put your model in production quickly. Shut up. Stop arguing. Stop creating excuses. Put your model in production, right? So this dynamic of organization is blocked because we have built architectures which are 3 decades old. And we fundamentally built an architecture which said whether you are an API developer, whether you are a data scientist, or you are a business intelligence user, you get a common platform. That's why it's an operating system. It's not yet another product, right? So I have 2 asks. There are a lot of smart people in the room. The first ask is for engineers, right? Stop integrating and gluing, for God's sake, right? I mean, we are creating a nation of, we used to have the services industry and now we created a nation of integration industry. I mean, it's just nonsensical. But we are just gluing this constantly and start creating IP or business moat via ML in production, not in theory, right? Show value continuously, right? Save $100 million, make $100 million, and then the executives will shut up, right? Then they'll let you do what you want to do. But if you tell them all the time, it's going to take me 4 months to deploy this, I need 5 Java engineers to do that, like seriously, it's crazy, right? So that's my pet peeve for the engineering team of India. And the second ask I have is for the data scientist, right? I've talked to lots of chief data scientists, chief data officers, and I've seen this myself when I've interacted with the machine learning scientists at Yahoo and others. It's okay to be academic, obviously it's a mathematical field and you have to understand the systems and we all need to have empathy for the math. But be decisive, right? Is this model going to work or not? Is this model going to show me X percentage revenue or not, right? Don't perpetually be in this boat of, hey, I don't know, it may work, if the traffic changed, so my model stopped working. I mean, what the be decisive about it, right? So that's why I tell this that do or don't try, right? There's no trying, just either you're doing it or you're not doing it. And just one last thing. So, who should talk to us, right? I have seen lots of people come to our booths and whatnot. So, if you're a customer who believes in this, if you are wanting to own your data, if you're wanting to create your own IP, definitely come and talk to us, right? As I said, we are speaking with 14 of the 30 unicorns of India with a lot of in-depth. And we can draw the TCP diagram with you if you are interested in. No marketing nonsense. I don't have a brochure, sorry. If you are somebody who, we call it the dark knights, as you can guess, I call myself the dark knights of Silicon Valley, right? You will never hear about us a lot. We don't do these things a lot unless Monish forces me to, but otherwise I don't show up on a stage and start talking about these things. But we are looking for people who understand substance, not Google for a solution, and challenge Google, right? Do what Sanjay Ghemawat and Jeff Dean did when they built Bigtable in 2004. They challenged Oracle. They challenged the predefined assumptions. You have to learn to go against the grain, and you will need a very thick skin for that, right? Whether it's sales, whether it's business development, whether it's engineering, whether it's product, we don't do the usual stuff. So that's it. It's going to be painful. I'll be warning you. So don't come to me for a job. It'll be very painful. But one good thing is that we don't go with experience. We don't go with, hey, you're a C++ engineer, I'll hire you, whatever. We're just software engineers who look for people who have the attitude to think like we think, right? Who should not talk to us right now? The people in suits? No. No, there are a lot of people who came to me and asked me about, hey, I'm running this services company and, can I use your product? And my customers are facing the same issue and, all of that stuff. genuinely would want to participate because we are not a services company, we are a product company, right? So we're not interested in helping, and sometimes our customers have the need for services, but just our size is so small that we doing partnerships and all of it, and we are just drowning in work. So there's nothing that I can do to help right now, maybe at some other time, right? But the people who should definitely not talk to us are people who try to steal our IP. There are lots of people who came and said, what is under the hood? Tell me what is under the hood. And I just point blank. Some of those were those suit guys, by the way. What do you do? How are you better than AWS? How are you better than SageMaker? Yeah, tell me that. So I said, look, I can explain to you, but it'll be unfair. I'm looking at electrons on a flash chip. How can I make you understand it? You will need a PhD in EE to understand it, right? So it'll be unfair of me to try to make you understand it. But that is also something that is very important. Why are we trying to copy? Why are there not 50 Isimas out of India, right? If we are doing that with 16 people, there is enough talent here, right? Don't try to be your own Isima in your own world, right? Because the meaning of the word Isima is imagination, right? You have to imagine that future before you can create it. And we are imagining it for some of the most boring things on the planet, the plumbing, right, essentially. But if you can imagine that, then ML will be truly powerful for humanity. This is my personal pet peeve, that all of these technologies came from the ad systems world, like the nuclear technology came from the defense world, but it has to go to better humanity. My doctor has to benefit from it, my kid's teacher has to benefit from it. And right now we keep on optimizing conversion rates and funnel conversions and whatnot, which is fine, it creates wealth, but let's get to the real world, right? The 90% of the world is still stuck in Teradata, right? Will you like it or not? So why are we there, right? And then we as engineers and technologists owe it to the industry and the society to make that happen. And nowhere better in the planet you can make it happen than in India, right? That's one of the reasons why we are here. That's it. Questions? Yes?
So just like yesterday, brilliant talk. I just want to, why should every company that's doing data have an SMA inside of it? Why should they not be solving this for themselves? Isn't that the job really?
Do you own a car? Yeah? Do you build your transmission?
I drive it myself. I figure out to drive it.
You drive it, but self-driving cars are coming. But do you build a transmission?
I don't hire an automated driver for my car. Right? Like
I know, but I asked you a very simple question. Do you build a transmission?
No.
No, that's it. That's why you should not build this thing themselves.
Okay.
You are reinventing the wheel. Productivity growth for the last 400 years has been by not reinventing the wheel. 10 years ago, people like you were asking, why don't we build our own data center? Just 10 years ago, we forget very quickly. 10 years ago, when Amazon was trying to sell, and now it's like assumed, I just run on AWS, right? That's the same way. By the way, does anybody know what BIOS came from? By the way, does anybody know historically what BIOS means?
Yeah.
Who? Yes? No?
Basic input-output system or something like that?
Yes, yes. No, who is that guy? Tell me. Stand up. Oh, great. Thank you so much. Only old people know that. But so IBM PCs created BIOS. When your phone, your Kindle, every single thing has a BIOS. Every single thing has a BIOS. It's basic input-output system, right? It's like your central nervous system actually. There is nothing basic about it, by the way. It's pretty complicated piece of code, right? Imagine if everybody said, that's what I'm trying to say. If you look back in history, people were building their own BIOSes. And then BIOS came, and then PC came, and then operating systems came, and then you print Hello World or you build a web server on top of it. That's what we want to do. We want people to take this BIOS and start building apps, right? Because that's what shows value, not the plumbing. And as I said, you can glue together all of this. You will just need 1,000 engineers like Flipkart. You are welcome to do that if you're going to build 1 billion impressions in a day. Or you can hire somebody to glue this together for you and hire consultants and make it work and make it operational and all of it.
I think where I'm coming from, I get that answer and thanks
Yes.
every user, every company,
Yes.
or every, let's say every use case is going to be different. And the transmission is going to be different for every car in that sense, right? So at the end of the day, something about it will need to be changed or being different.
Yes. And what is that? What makes you different than me? Or a chimpanzee, to be honest. We are 93, 99% the same, some number, right? What makes you different than us? It's this, here, more or less.
Well, I think it's about the people that I have met are different from the people that you have met.
Great, yes, but it's the experience which make us who we are. It is our responses to situations in life who make we are. It's what my kid makes my kid. That's why I say machine learning is like that. Machine learning should be like that, right? I tell my kid 10 times this is bad behavior, the 11th time he learns, right? But that's what makes him or her, right? Why are we building the engine again and again? And by the way, I have no problem if that engine can be built faster and with 2 engineers and whatnot. But there is an opportunity waiting here where we are building a chimpanzee instead of building a humanoid. I mean, these guys who have $1 billion in funding are not able to put ML in production. Do you think that all the training that is down there here and all the consultants that you have out there is going to match that? There are 4 companies in the world which suck up all the deep learning experts. Why does all the deep learning answer? Why was the previous speaker saying this comes from AWS, this comes from Facebook, this comes from Baidu, this comes from that? Because these 4 companies suck up every single talent available on the planet. And so instead of fighting them on their turf, you build a transmission and go and build your Ferrari. Oh, you are welcome to drive an auto though, by the way, and think it is a Ferrari. But we need to up-level ourselves and stop doing that. Sorry, go ahead.
Yeah, I think this is hypothetical, okay? I think I want to build a system, real-time system with analytics in it, which is Kafka, Hadoop, Spark, and a web interface, right? If I have to build a system like this, I think I'll need glue. Do you think that what I'm talking is not what you're talking about? And how would your system help in this kind of a scenario?
It's 180-degree opposite of what I'm talking about.
Okay, so I don't understand.
Yeah, so that's what I was trying to say. There are a lot of these people are like, okay, this is so much of a mess, I'm going to give you one more bomb to keep on doing it. Remember what I said, you try to run this, you try to take one of those open source technologies, go and run on that 60 terabyte box on AWS. Forget about 1 petabyte, just try to run it. Right? That's all I'm trying to say. Just try to run any of your applications on that 60 terabyte box and utilize it. Right? And then come and talk to me, I'll give you my stock options. Yes, please.
So, okay, if I'm audible enough, like what you said, there are many cases where the actual machine learnings or things we develop are never productionized. I completely agree on that. And I've told you an example myself yesterday.
Yeah.
So, and we also discussed about the stats where like 90% of data are still following the age-old traditional methodology, and that's where our hidden treasure is actually. So, what do you think is stopping the, things for us from, taking a step ahead from there? Because many a times what happens, or what I say is, people are very, very excited when they hear about this fancy terminologies on this data science, machine learning, AI, analytics, predictive, descriptive, prescriptive, whatsoever. Yeah. But when you actually come, this so-called data scientist, I'm a data engineer, by the way.
That's fine.
So they forget about what exactly is there back in my ecosystem or in my repository. They're so focused on building this algorithms or the training models that they actually don't focus on what exactly is the data there for.
Right.
So what exactly, I just want to understand what are the mindsets, because you guys are doing things differently, and you guys are, not doing this traditional methodologies of what we are currently following. So what makes you take that step ahead
Right. By the way, this is a great question, and I had this issue at Yahoo, right? So I was on the data engineering side, there was a data science team, the bunch of math PhDs. We had 3,000 PhDs in math. We had more data scientists than Google in 2006. More data scientists, okay? And when I say 3,000 PhDs, it's like freaking nonsensical. Stanford called us Google and Microsoft, the three players, and we were equal market share in search, and they said, academia doesn't have this much data. Why don't you give this data to us and we will police you? Because fraud is very difficult. Obviously, nobody gave them the data. But this was a real problem. Real problem was that these organizations were split. The incentives were split. One is a mathematician organization enjoys exploring data, which is fine. That's actually what you should do. But then there's another part of the organization which is responsible for keeping the lights on, and if click fraud happened, the CFO would call me. I was the principal engineer carrying a pager. Right? So, and I'm not kidding. I mean, this is like $10 million swings up and down, right? This is like, really, it's pretty crazy, right? So, they don't understand that world. They are not, they gave me a classifier which said, calculate the median price of a click, right? Have you tried calculating median of anything? It's a huge distributed scatter-gather tax, which whoever asked me the question of building a glue on website doesn't get it, right? So how do you do a distributed scatter-gather? And I'm talking when, again, 2006, so with Yahoo scale, I did the math and it'll require me 5,000 servers, right? That's how the heating cost of 5,000 servers was $8 million over a period of time and all that. So I said, can I do an average? No, that dilutes my model. I'm like, yeah, I know that it dilutes a model, but this will not go live. You have worked for 9 months, we are this close to it, and you're not letting me go this live because of this. And he's also right, and I'm also right, but that's it. It just stops, right? Similarly, we have to tell sometimes them that, you know what, should I get data from this other legacy system, right? Because what you're asking me is sitting in some other place, the search team has to change, 8 teams have to come together to give me the data so that I can run your model. Like, I don't care, it's your problem, right? So, this is the reason why there is a conflict between the data engineering and the data scientist. And believe me, I was not a data scientist, or I didn't even understand machine learning, to be honest. I was a systems guy, right? So I joined Yahoo. The first response is, machine learning is a black box. I do not understand what you're putting in production. My ass is on the line. I'm not going to put it in production, right? Because God knows what you'll do, right? And the data scientist is like, why are you not putting it in production, right? So this tension is always there, right? But the only way that so we put that classifiers in production eventually. The only way that gets solved is we basically created one team and said there is one manager on top of it, and you are responsible for running this classifier in production, keeping it running, ensuring that those classifiers don't atrophy, continuously looking for new features, but also continuously going in production, right? Because real life is pretty messy. Whatever sampling you do doesn't work. It all blows away the moment you try to do, especially with fraud. Because 3 a.m. some fraud in Korea happens, which has nothing to do with the US, and you wake up and you have to debug it, right? So all of that, the operationalizing part of it, was thought through in 2006 and 2007. And I'm talking of Yahoo, which was not close to where Google was, right? And I'm saying that Yahoo failed with everything we did, and from those learnings is what Isima was born, right? But it is truly a huge problem, the organizational part of it, and building empathy for each other, right? Building empathy that the data scientists, and believe me, I became a convert, right? When I saw those classifiers actually impacting $100 million. I mean, my boss used to tell me, like, you'll be shocked, 10 lines of code, $100 million. And I was like, yeah, no, she's kidding, right? But I actually saw that happen. So both sides have to build empathy for each other, as opposed to just saying that, hey, data engineering is slow, or data scientists are just academics, whatnot. You just need a single team who's responsible for delivering this in production.